Hello, everyone. As you file in, I want to let you know you're in the right place. This is the Safety and Health Magazine webinar sponsored by Matrix. Going to allow about another minute or so for everyone to file in and get settled. But again, we welcome you and thank you for joining us today. Once again, I want to welcome you, let everyone know you're in the right place. We're going to get things going in about 30 seconds from now. Thanks for joining us. Well, an official hello, everyone, and welcome to today's Safety and Health Magazine webcast, Visual AI, How Collision Avoidance Taps New Tech to Boost Safety, sponsored by Matrix. My name is Kevin Drewley. I'm an associate editor with Safety and Health Magazine and will be moderating today's session. Thanks for joining us. In a few minutes, we'll start our presentation, but first, let's review some preliminary items. The views of today's speakers and organizations are their own and may not necessarily reflect those of the National Safety Council or Safety and Health Magazine. Any mention of a commercial enterprise, product, or publication does not necessarily mean the council or magazine endorses those items. At the end of today's webcast, we will conduct a question and answer session. To ask a question, simply click the Q&A button at the bottom of your screen, type your question, and click the send button. Feel free to ask your question at any time during the presentation. You don't have to wait for the question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded along to today's speakers. At the end of this webcast, you'll be asked to complete a brief evaluation survey. We'll let you know more about that after the presentation. This webcast will be archived so you can access it after today's live event. To view this webcast and all of our past webcasts, please visit safetyandhealthmagazine.com/events. With that, let's go ahead and get started. Our speakers today are Brian Jones and Derek Bennett. Brian is Vice President of Sales and Marketing at Matrix. He has an extensive background and more than 15 years of experience in industrial and mining technology sales and management, particularly in the areas of collision avoidance and proximity detection. Derek is the product manager at Matrix. He's an electrical engineer with more than 15 years of experience working in the mining and industrial technology space. Again, we thank you all for tuning into this presentation. Brian, whenever you're ready, go ahead and take it away.
Thank you, Kevin. Thank you, everybody, for taking the time today to join the presentation. Again, my name is Brian Jones. Derek Bennett and I have both been at Matrix for 16, 17 years. We've been lucky enough to see a number of products launch, iterate, grow, develop over the years. We're here to talk a little bit about OmniPro and Vision AI product line, how it relates to AI, and specifically how we came to utilizing AI cameras for collision warning, collision avoidance. So why are we here? So my general thought is everybody here is either interested in the safety of their personnel or is a general techie that enjoys new technology. I think we've all seen these types of figures before. We put some up from the National Safety Council that relate specifically to forklift incidents. But we all kind of understand that there's an issue in the market, and hopefully we can shed some light on one of the technologies we believe can help resolve some of those risks and give you a little bit of insight on how to think about those. Quickly, this will be the only slide I read to you. Our goal here is to provide a general understanding of vision-based AI and how OmniPro utilizes that technology to provide collision warning, collision avoidance solution. We'll provide some general evaluation criteria from our experiences in the field along with that. So we plan on covering a general background of Matrix, give you some understanding of how we came to be and some of our experiences with collision avoidance, proximity detection, and the like. We'll have an overview of vision-based AI. We'll talk a little bit about AI, how camera AI functions. We'll have a general product overview for OmniPro, the Vision AI product line. And then we'll get into a little bit of evaluation criteria. So walking out of this, we want everybody to kind of understand if you do elect to implement these types of technologies in your environment, some things that we've seen that we think will make good evaluation criteria for you to be thinking about. So jumping into the background on Matrix. Matrix got started in 2006. This actually just 2 years before that, we actually started a project with our now parent company on proximity detection. So we did that in the mining market. For the underground mining application, we developed a magnetic-based system we call IntelliZone. And so fast forward to today, IntelliZone is the top technology used in underground U.S. mines today. And we're still, 15 years later, developing that technology. We're adding components and functionalities to that system. We have a very long-term view on product development and that life cycle, and we expect to provide new value for that particular product line for our customers, far into the future. But quickly stepping back to 2018, we decided to move from the underground mining environment to the surface and develop a system at that time that was specific for surface mobile machines. In approaching these kind of new markets and for collision avoidance, we leveraged that decade and a half of history and understanding on what technology to think about, how to implement these types of systems, how that impacts production, and all while providing a level of safety that we've come to expect. To do so, we had to explore a variety of different technologies, and we had 4 main criteria that we wanted to evaluate when we came to the surface. And so there's a reason for this background. When we came to the surface, we decided we did not want to have a personal wearable device. We did on the IntelliZone. We don't have that on the camera system. Reason there is you cannot gate all facilities. When you go underground in a mine, you can usually tell who goes underground. You can gate that environment. Not all environments are able to do that. And so we elected to move forward with a technology that didn't require that tag, and it could work indoors, outdoors, wherever it needed to go. It had to reliably and repeatedly alert on an intended object. So we need to be able to train that technology to alert on a person or a particular type of machine or a piece of signage or whatever that is, instead of just alerting on everything that it came into contact with. There's a number of reasons for doing that around zoning and things that we'll talk about here in a little while. It needed to be able to operate in a wide variety of environments, so both indoor and outdoor. Think about GPS. One of the technologies we looked into doesn't work very well indoors. And in a wide variety of environments, kind of where we landed. And again, it had to be price competitive. If you can't get a system to the market that is cost effective, it's not going to see the rollout. You're not going to be able to provide that level of safety that our end goal is for our customers. So we've looked through all of these different technologies. Honestly, we've worked with a number of these in the past. We've evaluated those, and we can talk to specifics on each one of those if anybody has questions on them. But we landed at cameras in camera AI specifically to solve what we believed were the requirements for the applications that we would have on the surface. So what is AI? It's absolutely everywhere. You see it on a daily basis. There are thousands of use cases being rapidly developed for AI. It's having an impact on the majority of people, whether they realize it or not. The most common use of AI that you might not notice is the facial recognition on your phone or the voice recognition that you use with Siri or Alexa or Google or whatever devices you may have. All of that is training a model that is recognizing either your voice or your face, and then applying an answer to what questions you may have to ask them. There are also different types of AI for medical devices that detect different diseases, and they're providing a lot of breakthroughs in the medical field. The one I've seen recently is this called a tractor in the center here, that detects weeds in fields and fires a laser to kill off certain weeds or pests that are in a field. So it's all over the place. It's rapidly developing. Um, Even within this large environment, there's a subset of vision-based AI, and that's what Matrix utilizes for the application of collision avoidance. In the vision AI space, there's still dozens of applications. For example, if you're looking at an intersection with a camera, there's a big difference in counting the number of people crossing through that intersection and identifying the face of someone in that intersection. Those are two, again, very different models that you're training to do that task. Both use very similar hardware, but both are a little bit different in how they actually perform their function. Both of those are different than understanding if someone is in a designated zone that we have deemed to be unsafe. And so we've focused our efforts on utilizing that specific technology for the case of collision warning and collision avoidance over the past 6 years, and have honed our model for rapid reactions and detecting a intended object inside of a zone where we either want to alert or alarm or possibly interact with a machine should somebody get into a zone. So maybe backing up a little bit, in simple terms, vision-based AI involves taking thousands of photos of objects or a group of objects that you want to detect or train a machine learning model on. And then that machine learning algorithm then determines, based on the objects you've taught it, a confidence level for any object that it identifies in a frame or a photo that is presented. You continue to do this with new objects, building out what we call an object library, which allows operations and facilities like yours to decide, in the case of collision avoidance, what types of objects you want to alert on, whether they be people, again, or different types of machines or signage. And again, we've built that object library, and over the past 5-6 years have worked to update it and refine that model to perform the function of minimizing false alerts and nuisances and optimizing the process speed for collision avoidance and collision warning. So when we talk about AI, there's always seems to be a correlated conversation around data. Thinking outside of the immediate advantages of retraining a model for certain environments to optimize that system, there are some rather cool things you can do to combine the ability to detect an object or a person in a zone with additional input data. So it starts to allow you to understand maybe where your most dangerous intersections are, or the most hazardous times of the day, or demographics for operators that are working more effectively or safer than other operators, or maybe even what types of machines are safer to operate or involved in more incidents and things of that nature. I'm sure the people on this call can probably identify a lot more use cases or insights than we've been able to for that data, but and we're always open to take input there. But that gives you kind of a general overview of how we think about AI and camera AI in general. So I think next step here, I'd like to jump into introducing the product line. To do that, I need to show you a video, and so I'll jump out of our presentation real quick and jump into a video. It's about 3 minutes long, gives you a high-level overview of the Vision AI product line, and then we'll get into a little bit more detailed discussion. So let me jump into that real quick. Oops. Play real quick.
When a 1-second error can mean the difference between a near miss and a lost time incident, you need the most advanced, accurate collision avoidance system working for your team. The OmniPro Vision AI collision avoidance system uses Matrix's exclusive visual artificial intelligence technology to detect people or key objects in a forklift's path of travel. OmniPro is easy to install, configure, and operate. The system can function as a standalone unit and alert the operator to help avoid a collision, or can be machine integrated to slow or deactivate the accelerator pedal when an alert zone is breached. OmniPro Vision AI's alert zones are adjustable to match a specific operating environment. Each camera is configured individually, which means it can be tailored to any material handling equipment regardless of make, model, or size. Most operators use OmniPro to generate 2 primary alert zones. A caution zone, shown in yellow, triggers a visual alert for the operator when the zone is breached. In machine-integrated systems, this also reduces the forklift's speed. The alert zone, shown in red, triggers a visual and audible warning when someone enters the vehicle's path of travel. For equipment with machine integration, a red zone breach disengages the accelerator pedal. OmniPro Vision AI assists the operator in situations where people or equipment may be operating in blind spots, or the operator is temporarily distracted or fatigued. OmniPro can identify people in various positions, including standing sideways, crouching, kneeling, and partial view, as well as workers wearing PPE. Each alert zone breach is photographed and time-stamped. OmniPro Vision AI can operate up to 4 cameras, and each camera can project up to 5 independent alert zones. Options include an in-cab display monitor, a highly visible pedestrian alert lighting system, and machine integration. For 2-camera systems, OmniPro Vision AI automatically switches cameras to only detect in the forklift's direction of travel. The system can alert for as many people or objects as is required. Connecting with OmniPro is easy, with Wi-Fi, cellular LTE, or Bluetooth. The OmniPro Cloud can provide decision intelligence reports on-site or remotely, helping you make smarter, more informed decisions to run a safer operation. Matrix has been in the collision avoidance business since 2008. Our experience and ongoing customer input have enabled us to create a powerful collision avoidance system that minimizes nuisance alerts while maintaining productivity. OmniPro is designed for harsh, rugged environments like warehouses and manufacturing facilities, and will withstand the high vibrations caused by fork trucks and other material handling equipment. Take your forklift operation safety to the next level with OmniPro Vision AI.
Jump back into the presentation here. So, a quick overview of the system. This is a quick breakdown of the OmniPro platform. So we have 2 main components, and there's a number of other components we'll walk through here in a few minutes. The biggest 2 components are, of course, the camera and the hub. So the camera is again, AI-based camera. That all the processing actually happens inside of the camera, so you don't have to worry about cloud connectivity or any of that type of thing. We built a model to work on the devices. You have the hub, which is a networking device. There's some processing and configuration that does happen in the hub. There's some logic inside of that hub, but primarily its job is to push data back and forth as needed. So you have all your cameras that are connected to that hub. You have your antennas. You have your cabling power and whatnot that is hooked up there. And we'll go through that entire connection here in a little bit. Then you have what we call the brain, or in focus, is our app. So you have a cloud-based software platform that gives you access to all your data reporting, and we'll walk through a little bit more detail on that here in a little bit. So the system in general, again, we've worked 5 or 6 years, 7 years some, on ensuring that this is a accurate, high-speed system that is meant to do a specific job of identifying a intended object in front of a mobile piece of machinery and giving that operator enough time to react. And so that's got to be a quick processing speed. We've learned that over the past 15 to 20 years working in these different environments. We currently process at around 30 frames a second on the camera. That gives you a lot of information that is coming through at any one point in time. You can have up to 4 cameras right now on the system. You can have an expansion that'll give you more than 4, but inherent to the current hub is 4 cameras. Each camera can project up to 5 zones. So if you have a straightaway zone that you want to put on that has an alert zone in yellow or in a slowdown zone in red, and then maybe you have some zones off to the right or left that you want to add in for different purposes. Again, as we kind of move through this presentation, think about how risks at your facility and how you might be able to apply these systems in those environments. Again, we alert on pedestrians. Primarily, that's the biggest need we see. We also alert on different fork trucks and different types of vehicles and stop signs and things of that nature. We've trained the model to do that and can expand that as needed here. So another piece, we have a number of different interfaces with the machine. We have Wi-Fi, cellular LTE, Bluetooth, GPS. We do have the ability to do CAN and some other protocols. So Derek might touch base on those here in a little bit. But again, all that is to communicate data up to a cloud that gives you the information you need to make decisions. And focusing in on the camera a little bit. Again, it's built to be a accurate high-speed detection device. We've got a number of sensors inside of that, outside of the camera. We also have a sensor that is meant to detect if the lens is being blocked. So that is one issue with some cameras in the field, that if the lens gets dirty or if it's being blocked by an object or something of that nature, camera doesn't function properly. So we put a sensor inside of that to understand if there is anything blocking that camera, so that we can flag an alert that the system isn't working properly. It is a low light camera, so we like to say that, if you can't see where you're going, you probably shouldn't be driving the machine anyways, but it is a low light based camera. It works, intended to work in a lower light than the human eye. But again, if you don't have lighting on your machinery and you're operating at night, that is a risky environment anyways. But is also rugged. So we come from the mining industry. We build things that are hard to break. There's an old adage that a miner will break an anvil. So we build things that are meant to be tough. And so it's weather and water resistant, but we like to say you can always find a way to get those in there. But they're meant to be in harsh environments, and we put them into those. So again, there's custom zone setups that are done through the hub. Each one can have up to 5 zones, and there's a wide variety of connectivity options there. Into the hub component, again, this thing is it's designed to be a networking device, but there is a decent amount of logic that is built into the hub. If we see X, we can do Y, and so we've got a nice logic engine that is built into that. There's ports for different harnesses, and we can do a lot of different things with harnesses on connectivity with different devices, third-party devices, machinery, that type of thing. There's, again, we mentioned CAN earlier, a number of antennas for remote GPS or remote GPS, Wi-Fi, and cellular antennas. And then we have USB and HDMI or HDMIs to run to an external monitor. It can run up to 4 cameras with the inherent ports on the hub. We do have the ability to put an external switch to add additional cameras. That's just changing one of the code in one of those ports. Again, multiple I/O function. There's 5 digital outputs, 5 relay outputs, and we take an input from the machine, typically tapping into a reverse signal to understand if we're moving forward or reverse, and then we can tailor the system to either in forward, we only show a forward zone, reverse, we only show a reverse zone. There's a number of things we can do there with different inputs. Really quick on the cloud, and we'll talk a little bit more about the cloud later. You're going to get zone breaches. So anytime a zone is breached, you'll get a cadence of photos that are time-stamped that show what zone has been breached. You'll get pre-event and post-event. So and those are configurable. Some pre-event images to understand what led up to it, and then post-event to understand what happened afterwards. We have an analytics suite that we're developing. We have some of that functionality now. We'll continue to develop that as we scale up. That gives you a wide variety of reporting for your average daily breaches, or again, what types of machines are having incidents, or what operators are having incidents, and we can provide some custom reporting as needed. Again, we'll touch base on some more of this here in a little while. 3 key components here that we haven't really touched on yet. Machine integration. We have the ability to slow a machine and with regen braking actually stop the machine, depending on if it's an IC or an electric machine. We don't integrate with the brake pedal. We've always seen that as an issue with actually hitting the brake with a load on the machine. So we inhibit throttle. It will remove it to a certain percentage of throttle if you hit a certain zone, and then we can remove throttle altogether if you hit the red zone. Again, with regen braking, that will actively slow down the machine. You can do that with some ICs. On some of the ICs, you may see it move into a coast. Either way, the operator is going to understand that something has happened with the machine and take action. We also provide an in-cab monitor. It's not required, but we do have it available. We'll show, and then you have the alert lighting on the right there. In-cab monitor is useful for understanding where around the machine there is an issue, and if it's forward or reverse, they can quickly evaluate where that is. It's more critical on larger machinery, but we do have a number of fork trucks operators that are interested in putting that in their cabs. Again, it's not just the monitor. We have alerting, lighting, and audibles. So those are based on the zone that is being breached. So we can tailor either the light or the audible to be different based on the different zones. So I'll run through this real quick, and then I'll pass it over to Derek on the next slide. We'll run through the components. Again, in the middle of the screen there, you see number 1 is our hub. Attached to that, right above the hub, are our cameras, and these are all to scale so you can understand a little bit about how big they are. Just below the hub is the cellular and GPS antenna that can be mounted right near the hub, or it can be mounted remotely. To the right, you see the cabling harness. Again, that's Derek can go through a little bit of how we install that and what inputs we can take and how that actually functions. To the right of the harness, you see the monitor. Again, it's required. It's not required, but we see a number of people that actually want to put that in to understand where people are in vicinity to the machine. Above that, you see the indicator lights. We have a couple different varieties of indicator lights. This is the one that has a audible included with it. And we see that preferred in a number of different cases. The rest of these are mounting brackets for each one of those devices. It gives you an idea of all the components that actually go into the system. Now I'm going to pass it over to Derek on this next slide and let him run through how we system layout and how we actually.
Yeah, thanks, Brian. Good afternoon, everybody. Brian has up here, it's kind of just a general layout of the OmniPro system. As you've seen on the previous slide, it had each of the components, but this is going to kind of give you an idea of how things interconnect. So in the center, Brian mentioned that's our OmniPro hub. It's the main system component. And from there, we can connect up to the 4 cameras Those cameras will be connected via an M12 Ethernet cable. Standard cable length is around 5 meters, although we do have some different length options for different applications, but a standard kit would have that 5-meter option. We can hook up to 4 cameras, and on those connections, it's going to provide power and data to these cameras. So it's just a single point of contact from the hub to each of these cameras. From there, there's also the antenna connections. You can see this cellular and GPS puck style antenna. That's like a combo style antenna that would be mounted, as Brian said, it can be integrated in the hub mounting system, or if it has like some enclosed cabs, we'll sometimes have to run those to the external side of the machine. So there's an optional magnet mount that's available for that. There's an additional Wi-Fi antenna that you can have connected to your company's Wi-Fi infrastructure. Sometimes people put on maybe a guest network or work through those security concerns with their IT to get this stuff on the network. One thing I wanted to stress is that any kind of Wi-Fi, cellular, or GPS connections are all optional. There's no requirement for these to be connected to any external connection. This can be a standalone system, but for the different analytics suites through the cloud, we would have to have some type of connection to get that data out for it to be resided in a cloud solution. Down at the bottom left, you can see the optional display component that would be plugged into an HDMI port there. Again, the display is also optional. A lot of people opt to have a display, mostly on heavier equipment, so where they have particularly large blind spots, so they're not only using the cameras for alerting for pedestrians and obstacles, but they're also just using it for a general visual awareness of the machine around them. Up towards the top is our system wiring harness. Through this connection, we would get machine power from the machine. We can take anything from 12 to 48 volts DC to power the system, so we have a wide operating range for different applications. Anything that would be above a 48-volt operating range, we would require a DC to DC converter. Some of these systems, a lot of these new electric trucks, with the lithium-ion batteries, we keep seeing those voltages increasing as the years advance and stuff. So if there's anything outside that operating range, we have some solutions to support those. Through this harness, in addition to providing power, we're also going to pick up machine inputs. We have 5 digital inputs and 5 relay outputs that we can support. There's 2 analog inputs available. So that would be all of the machine I/O that we could use to integrate. Typical machine integration signals that we would be looking for is a direction of travel that we typically pick up off of a reverse backup alarm. Also, we're looking for a motion or a presence signal. So either we have an amp clamp solution that we can hook on. So if there's motor current, we know that, and this is on electric trucks, but if we see motor current, we're in motion. Or sometimes we'll tap into a seat switch for operator presence, which that would activate the system. Other things going through the integrated harness would be communication protocols for further machine integration. We have CAN bus support. We're targeting to have J1939 support maybe in the 3rd to 4th quarter this year. That's still in development, but we do have the hardware to support that. And then also any kind of proprietary CAN, we would have support for that as well. There's also a serial RS-485 communication on board to communicate with any kind of peripheral devices or telematics solutions that might be out there. That's some things that we could potentially integrate into. And then these last 2 connections are just the integrated cables that connect to the audible and visual alarms. So that's kind of pretty much the layout of the system. And if Brian wanted to go to the next slide, we can start talking about, some different mounting solutions. So here's a typical truck. This is in our Newburgh, Indiana facility, our main office. And we have a truck there that is kind of our guinea pig where we do a lot of testing in-house. And the left camera or left picture here shows a forward-facing camera. We use magnetic brackets that have some very strong magnets to mount these out on the forward mast of a fork truck. We try to get this camera protruding out as far as we can on the front of the system to get a nice wide view out the front. Our cameras operate at 120-degree field of view out the front, and same on the rear. So it's very wide and to get that that viewing angle around the other side of the forks of the machine. The picture on the right has a rearward facing camera. And again, it's got a magnetic bracket on there. We utilize the magnets just because all these are structures that we're attaching to are engineered design. So it would defeat the engineered design if we were to drill or tap or do any other kind of mechanical means of fastening these devices to the machine. So magnets seem to be low impact, and we've actually had exceptional luck with that solution. So the next slide. Again, here's another viewpoint of some cameras mounted. The one all the way to the right is the forward camera. This is a stand-up truck here. And on the rear, we have that rearward facing camera. You might notice that, oh, that thing looks like it's upside down. That's one thing I wanted to note is we can mount these in any angle. So it could be horizontal, vertically, and through software, we can change that rotation to support the application and the install. There's a couple arrows here also pointing at the visual and audible indicators. We'll typically mount one in the front and rear. That way, we're trying to make sure that in any orientation that operator is in his cab, he has some peripheral visual alert happening when a pedestrian reaches a zone and activates those alarms. It's kind of hard to see, and I should have had an arrow pointing to it, but we actually have that hub. It's in the center, mounted on the overhead ROPS, or the overhead guard there, and we have like a clamp mount. Yeah, Brian, thank you for that. So like that's the central hub that's connected there. And on top of that would be the antenna and all the cabling running to the devices. So next slide, please. So this is kind of just to give a quick explanation of what we're doing. So we have our forward camera and reverse camera, and in an effort to reduce nuisance alerts and, you know, annoy operators and, you know, cause them to become complacent of the alarms and alerts that are coming through, what we'll do is we'll integrate with the machine. And as I mentioned, we're typically looking for a signal, whether it be forward or reverse, and then also a motion signal that's going to enable that that signal. So in the reverse travel, you can see we have two zones, a warning and an alert, and these zones can be configurable, but we're only going to activate those reverse zones when we're moving in a reverse direction of travel. Same with the forward, we're only going to have those zones active and alerting when we're traveling forward. In these layouts, there's a few things here. It's kind of just giving everybody a general idea of mounting locations. So you can see the blue boxes where we'd have our cameras mounted. So on aftermarket solutions, we've been mounting the OmniPro hub on the overhead guard. The yellow circle there you can see is our GPS cellular antenna that's mounted on top. And the red little indicators are where we would typically mount our audible visual alerts. There's a few general cable routings that we have there. And then again, the only thing that we require is that power connection to the machine. And again, that would be a 12 to 48 volt power connection. So next slide. Okay, here's a good example of what a warning zone breach would be on the forward motion of a truck. So this truck would be in forward. As you can see, we have an enabled yellow in a warning zone. And in this picture here to the right, you can see this grid pattern with it's a very opaque red and then a slightly opaque yellow zone. And on these, you can see how a person is detected by the machine, and then how that intended object that we're detecting is intersecting with the zone to initiate a breach, is what we'll call it. So this person has been detected by our machine learning algorithm in real time. We're going to be capturing these frames at 30 frames a second and inferencing on them to determine if there's a presence of an intended object in there. This person is detected, his box is intersecting with our yellow zone. So this constitutes as a warning zone breach. What this would look like for the operator is he has a yellow light blinking in his cab, letting them know that, hey, there's a person out there. If he had an in-cab display, that he would visually see this in his in-cab display, the same image on his display there. And if it was configured to do so, we would also be logging images of this zone breach event. Brian kind of touched on it. We have it configurable to take pictures both pre and post. So as this truck was approaching, we would have up to 5 seconds before the truck approached and that the person or intended object intersected that zone. We would capture images through the duration of that breach. And then we can also save images up to 5 seconds after that breach. So with all that data within that zone breach, it kind of paints a story of what happened leading up to that breach and after. And if there was an incident that needed to be reviewed, personnel could go back, look at that data, and kind of, you know, get a real story of what happened as the moments leading up to that incident. So the next slide, I think, should have an example of a red zone breach in the reverse direction. So this machine's operating in reverse. We have a red zone and a warning zone coming out the rear of the machine. And then here's an example of a person that stepped out right behind, you know, the propane tank of this IC truck, and it's alerting on a red zone breach. So that box is intersecting with the red zone. And again, the operator will get a red zone red warning light coming through on their audible visual in the cab. This would also provide an audible alert to them to make sure that they're getting their attention drawn to the hazard. And again, we would also be saving and storing images for this event as well. So the next slide. Yeah, so this is just kind of giving an example of how you would configure the zones to be tailored for your environment. There's all kinds of different zone profiles, and we can increase the grid to add granularity of what size and shape these zones need to be. They're customizable for what we would want to alert on. So we could, you know, maybe have a yellow zone that's going to alert on pedestrians and fork trucks, but then maybe in the imminent red zone, you would only want to alert on people because that's our main focus of, you know, trying to prevent those collisions. But there might be a third or fourth zone that could be out even further that could alert on different objects. Again, it's just kind of customizable for the different things that you would want to be alerting on. One thing to mention is the further these zones will be out, the further the detection ranges will be out. You kind of walk a fine line of configuring these because getting the zones too large, depending on the mounting height and location of these cameras, you might be alerting on pedestrians that could be on the other side of the warehouse. And we try to prevent and tailor these zones to not be alerting unless there is a danger or a hazard at bay. The main purpose of that is to mitigate the alerts that the operator is going to see, because if they keep getting, you know, all these alerts continuously, they'll start to get complacent or start to lose faith in the system. And that's something that we're constantly trying to, you know, avoid. These zones are configured through software. Our system doesn't require like an external software solution. It's all like a web-based UI system. So what you would do is walk up to the truck as a service tech, or if you had your personnel that would be, you know, managing a system, or if you had us managing that for you, we would connect up to that system wirelessly, and through a web user interface, we can adjust zones and make, you know, system changes and, you know, kind of tailor that system to work in your environment to help solve the problems and, that you guys are facing for your environment. A couple other things that are on there is we have everything password protected. You can export files and configurations to have them saved off. For a component replacement, everything is designed to be plug and play. So you could just unplug a component. If there is a component failure, plug a new device in, and then the software would be able to reload that system without having, you know, high technical expertise to support that. Looking through, I think I covered everything on that slide. So maybe pop to the next slide there, Brian. Okay, so this is kind of giving an example of like a machine interacting in a work cell with an employee. And as you can see, this is a very busy environment that this truck is interacting in. This is an order or a truck that's been picking supplies and equipment, and he's loading them and dropping them off into this load cell or work cell. And if you can squint your eyes enough and see, there's actually a person standing there, and as this truck comes in, yeah, he's got a blue shirt on, and it's kind of difficult to see with some other blue things that are happening there. But as he approaches, that operator enters into the warning zone. So that operator will get a yellow alert. And if we had speed integration, that would start to slow that machine or reduce their throttle. And as that truck, continues to advance in there, that intended object or that person is going to start to breach that red zone. And at that point, that red zone would inhibit speed or, take it down to an idle if we were integrated, and also provide a red and an audible alert to that operator. And this is just kind of outlining the sequence of events leading up to that. And then if you're doing a data review through the cloud, kind of what that data would look like as you go through it. And I think we have one more example that we could go through. And this is just kind of showcasing, not just pedestrians, but other mobile equipment that we can detect. We detect other fork trucks, and there's a whole bunch of different things that we can configure to test or to detect on. And that's kind of one of the strengths of Matrix, is we do all of our machine learning and AI development in-house. So we have trained machine learning and data scientists that can work through data for your locations and work to make sure that that model is going to be performing at an optimum level for your environment. So with that, I think that's everything I was going to cover, and I'll kick it back to Brian.
Awesome. Appreciate it, Derek. So I'll just doing a quick time check. We'll kind of roll through the cloud discussion pretty quick here and then get into evaluation considerations. We want to touch on those. So basic use case for the cloud, we want operators to understand where they're at. And so when you get these systems installed, you'll basically start getting data back through the cloud application. You'll understand and develop a baseline of where you're at right now with respect to zone breaches and how many incidents you're having a day that you may not be aware of. From there, you start identifying what environments or machines or locations or whatever that is may be the highest concern for you, and you're able to start measuring improvements. And so you can see, here's the issues that I'm having. Next step is how do I take the next step to actually improve that environment, talk with the operator, whatever that needs to be in your facility to move things forward. We're wanting to give you a platform to give you the information that you can go and make decisions on and move from reacting to incidents to being proactive and actively preventing those incidents. Again, gives you the real-time access. We have some analysis and some trending, and it gives you all the events. All those things will come standard in the platform. Gives you 24/7, 365 access to data from anywhere you need to understand what's going on in your facility. It gives you a quick screenshot of what it looks like. We're again continuously developing this platform that gives you a general idea of when events occur, what you see in the cloud application, and what you might expect. So I'm going to jump through there. There's a wide variety of applications for the Vision AI platform, anywhere from haul trucks and large mining operations all the way down to reach trucks and forklifts. We've tried it on a wide variety of different machines and have been very successful in these implementations. So if you have a specific type of machine you're interested in trying it on, feel free to reach out. We're happy to have those discussions. Speaking of implementations, we do have some evaluation criteria that we've kind of worked through and understood over the past few years that we think are very valuable to think about when you're looking at introducing these types of product lines. And so we'll run through these 10 real quick. I'll give you kind of a high level. And if you have any additional questions, feel free to reach out or ask questions there in the chat. So on the defining a problem, I heard an interesting saying the other day that a problem well stated is a problem half solved. So if you can define that problem well enough, you've understood the technology that you need to implement, the environment that you're putting it in, the issues and concerns on the different types of machines that you're thinking about, the rates of occurrence, the time of day, the machines that are involved, the location in your facility that it happens to be occurring. you want to bring all that data together and then apply it toward a pilot or a trial of the different types of technologies. We work with a number of different operations where one operation may be, or vertically integrated companies where one operation may be entirely different than another operation. So our system may fit very well in this specific environment, and maybe need to be tailored a little bit for a different environment. And so I would ask, we encourage everybody to try out different technologies. I would ask those vendors that you do try how they've solved the problems before in your specific environment. And, get references and that type of thing. We're happy to provide those, and I think most vendors are. But ensure that they are willing to test their technology inside of your environment to make sure that that's actually going to work to solve the problem that you're trying to solve. Again, on the technology side, explore the options. We mentioned earlier a wide variety of different technologies that can solve a collision avoidance risk, but does it fit the environment that you're wanting to try at your specific facility? It's worth checking out multiple technologies, piloting those, let them run, and making sure you have the right tech before you scale up and implement a lot of these. Components, we've mentioned the components a few times. Make sure that they're rugged, fit for purpose. They're rated to meet your environment. If you have a very, very wet outdoor environment, make sure they have IP ratings. And then they need to be easily replaceable. So if you're putting on machines and these are custom attachments and they take a lot of time to replace, that's going to impact production. So those things have to be plug and play. They have to be able, you can smack a camera hard enough that it shatters the lens or something along those lines. You probably have some other issues to consider, but make sure that you can unplug that thing, plug another one in off the shelf, and you're back into production and running without having an open risk inside of the facility. So functionality, there's basic functionality around alarm and alerting, some basic reporting and software on cloud platforms you'll see from most technologies. You want to ensure that functionality of that system solves the problem that you want to solve at your facility. You can have all the bells and whistles that you want, but if that core functionality of slowing or stopping or alerting an operator of a person or machine or intended object in a zone, if that doesn't work reliably and day after day repeatedly, then all the bells and whistles don't matter. The thing's got to work to improve safety in your facility, or else the rest of it is not even worth considering. So think about that. Think about companies that are looking to the future and what is next on the pipe. What other technology is coming along? We'll talk about that in ongoing development, but consider that as well. Over the past 15 years, there's always been a conversation with safety versus production. It never seems to go away. You want to make sure that the system that you are implementing can be tuned to your operation. There's inherent issues with some different technologies with tuning it to fit inside of narrow aisleways, for example, or if it works outdoors versus indoors. Make sure that thing can fit your operations. All of these different types of systems may have some initial level of impact to production while you're doing trials or while you're doing pilots of the systems. But if the vendor you're working with can tune that product to fit your specific environment, that impact is reduced dramatically. You just need to understand what the business is willing to endure and how well that system can be tailored to meet your environment. There are a wide variety of benchmarks in the market. I won't really dive into those. You can get vision-based AI benchmarks from automotive. You have the false alerts, the false positives, the true positives and true negatives. You have what we call an F-score, which is a metric for evaluating is the system doing what it's supposed to be doing. Those benchmarks can be found online. If you have any questions, we can send you some of those if you're evaluating different camera systems versus one another. Again, jumping into the testing and feedback, you really need to have a champion. And this is for any change inside of your facility, you need to have a champion that's driving that. And I think most understand that. But you do want to solicit internal feedback. So you want to keep operators that are bought into understanding that keeping the status quo is a risk and that change is a good thing. Putting those operators on the pilots, getting feedback on how that thing's running on a very regular basis is very valuable to understanding, is this system going to work with the rest of the operators in my facility? There's objective and subjective feedback or metrics that you want to run with. Objective is useful, the KPIs and all that is easily measured. You really want to get that subjective feedback from the operators on and how is this going to affect my daily routine. Price, again, you can do anything with enough time and money, but a lot of us don't have those luxuries or budgets. There is technology that exists in the marketplace right now that can do everything. There's sensor fusion, there's automated machines, there's all of that type of thing. If you want to solve the problem on your existing fleet, there are technologies in the market now that can do that at a cost-effective price point. Integrations, you need to be able to retrofit your existing fleet with these systems. So think about how you would integrate with the machine, how you would integrate with OEMs in the future, what third-party integrations may look like with telemetry systems and impact systems and production systems, and how those data integrations fit with different software platforms. Ongoing development, again, I mentioned that earlier. You want to ensure that the vendor you're working with is thinking about future development. Technology evolves fast. You don't want to be left behind. 4 or 5 years from now, that technology curve is going to be moved way ahead. So work with a vendor that is thinking about what are the next steps, how do I iterate, how do I utilize my existing platform for the next sensor set or the next sensor suite. Ensure that vendor is having those conversations. And support. You can put this system on, it works great on day one. If you don't have a support system behind you, none of this matters. You've got to be able to call somebody that's going to answer the phone and be able to walk you through it or come on site or be able to work and have someone that is experienced and knowledgeable on that product support team that can work with you to make sure that you are implementing this correctly, that you're trained up properly, that you are being walked out and implementing this system in a way that provides you value moving forward. So we'll wrap it up. Again, just Matrix in general, everything's built here in the USA. We pride ourselves on exceptional service, high quality product lines, and working with customers and partners to build a solution that fits a specific requirement. We're headquartered in Newburgh, Indiana, just outside of Evansville, Indiana. We invite anybody to come down and see the headquarters, run a demo anytime you want. And with that, I'll wrap up. Again, thank you all for coming, joining us today. I know we went a little bit longer than I expected to, but hopefully it was valuable. I think we have a couple poll questions. If you have a couple 20, 30 seconds to answer while we pull together questions from the team, we really appreciate any feedback. And then we're happy to answer any questions you guys might have.
All right, excellent. No, as we do get those polls up, we'll get things going with the Q&A. Well, no, certainly great job, both of you, Brian and Derek. Thanks for sharing your insights and expertise. Before we do get to those couple of questions, just want to let everyone know about the evaluation survey that we're asking you to complete. The survey will open at a different screen after the webinar, and we appreciate your input as it helps us improve our future webcasts. As with the top, if you want to get a question in there, it'll be forwarded along to our speakers today if we don't have time for it, but you just need to click that Q&A button at the bottom of your screen, type your question, and click the send button. Getting to that first question, guys, will this work on any make and model of forklift?
Yeah, I could take that. Yeah, so we can operate on any make and model. The only requirement that we're going to need is a voltage source, and that's going to be anything from 12 to 48 volts DC. And as I mentioned earlier, we can operate even outside of that range just as long as we have like an external DC to DC converter on it. We've been integrating with different machines as the weeks and months go on, we're always facing different machines. I know most of you guys on the call probably have mixed fleets or varying, ages of machines. And we've kind of really designed the OmniPro product line to support and be adaptable to all types of applications. So if you guys have any specific application concerns, again, you have our contact information, and don't hesitate to reach out and we can discuss how we can get OmniPro on your systems there.
Running close on time, but I think we can probably get to one more. How long does this take to install, and does it take video?
Yeah, so first, typical installation without machine integration, and I'm saying machine integration with speed control would be around 1.5 to 2 hours. Everything's magnetic mount, and there's a clamp mount up above. So, we really tried to design this thing to be, scalable and with plug and play connections, and an integrated harness really reduces all the need to have like any kind of custom wiring or anything on that machine. Related to images and video, we do not take video, but we do take images at a high resolution. So we can capture images up to 2 images per second. And with a pre and post image data collection, you could kind of click through an event and it would almost look like a stop frame motion film, but like you would have these images and be able to see those. And that's really just, instead of taking 30 frames a second, we're taking 2 frames a second. It's still going to tell the story, but it's going to reduce that data consumption of what we're, storing both locally on a device or pumping out externally to our cloud solution.
Well, thank you. Unfortunately, we have run out of time today. Sorry that we didn't get to everyone's questions, but again, all of today's unanswered questions will be forwarded along to our speakers. And once again, we hope you take the time to fill out that forthcoming evaluation survey and give us your feedback. With that, we end today's Safety and Health Magazine webcast. We'd like to thank Brian Jones, Derek Bennett, everyone at Matrix, and all of you who listened in. Thanks and have a great day.